So just like a really quick special right triangle review, okay? So there are two special right triangles. We technically use the 30, 60, 90 twice, all right? So the first special right triangle in the unit circle, the first angle in the unit circle you're going to memorize is 30 degrees, all right? So what you're looking at is the general form of a special right triangle that has 30 degrees. So this is what the unit circle is going to be. A unit circle is a circle that has a radius of 1. So the radius is the diagonal. So you can see I put a 1 there. What we want to do is use the special right triangle rules to get the other side lengths. Eventually you're going to memorize the other side lengths, but I don't want to just give them to you. I want you to at least see where they're coming from, okay? So in a 30, 60, 90 triangle, the hypotenuse is double the small side. So if my hypotenuse is 1, then that 1 is in the 2A spot, right? So like, I'm just taking the formula for the hypotenuse and I'm setting it equal to what I know the hypotenuse actually is. And I can take that and solve it for A. So I can divide both sides by 2, and I get that A equals 1/2. Well, A is the small side of the triangle, okay? So what this tells me is the 30-degree side of the triangle is 1/2, right? Because if that's 1, and that's double the small side, so half of 1 is 1/2. And then the 60-degree angle side is A times √3. So in this case, the small side is 1/2 times √3. So this length would be 1/2 times √3. Another way to write that is √3/2. All right. So if the diagonal of the triangle is 1, then the short side is half of that, which is 1/2. And the other side is 1/2 times √3. And I'm just writing it as √3/2. So one of the side lengths that you're going to memorize is going to use the numbers 1/2 and √3/2. And it'll make more sense when you see it on the circle. All right? So that's one special right triangle that we're going to use. The next angle that is in the unit circle is not 30, it's 45. So like the unit circle starts to progress. So it's 30, and then we hit 45, which is another special right triangle. So in the unit circle, which you'll see in a moment, the hypotenuse, the radius is always 1. It's a unit. That's why it's called a unit circle. So in this case, the 1 is in the A√2 part of my special right triangle. So I can take A√2 and set it equal to now what I know the hypotenuse is, which is 1. In other words, the A√2 and the 1 are in the same spot of the triangle. The triangle on the left is the formula. The triangle on the right is the triangle I'm working with. So if I wanted to solve this to get A, which is the two side lengths here, I can divide by √2. And A equals 1/√2. And then I'm going to just rationalize that by getting the √2 out of the bottom. So I get √2/√4, which is 2. So this side length is √2/2, and this side length is √2/2. That's just special right triangle rules. If I'm losing you and you're like, what is this woman talking about? You don't need to know the process. You need to know the numbers. So eventually, you'll just memorize the √2/2. All right, it's not that many numbers to memorize. It's 3 numbers that you're memorizing. All right. And then the last angle of the unit circle is 60 degrees. Now this is like an alternative of this, because you can see the bottom corner of the formula triangle is 30, but I want 60. But you can see there is a 60 in the triangle. All right. So what I'm going to do is I'm going to work with the hypotenuse. The hypotenuse of the unit circle is 1, and the hypotenuse of the formula is 2A. So I can solve for that short side length by dividing by 2. So the short side length is half of 1, which is 1/2. The trick here is that the short side length is opposite of the 30-degree angle, and I have the 60 in the corner. So I'm not gonna put the 1/2 here, I'm gonna put it here. I'm just turning that triangle, okay? And then the long side length is A times √3. You can also write that as √3 over 2. This triangle is the same as the first one. I just turned it. So there are 3 values that we've seen. We've seen a 1/2, we've seen a √3 over 2, and we've seen a √2 over 2. Those are the 3 values of the unit circle that you're gonna memorize, all right? So now we're gonna actually work on the unit circle. So the unit circle is a circle that has a radius of 1. That's why it's called unit, so it's 1 unit. The angles that you're gonna need to know on the unit circle, you already know some of them. You know where 0 degrees is, you know where 90 degrees is, you know where 180 degrees is, you know where 270 degrees is, and you know where 360 is. They're on the edges, right? So yesterday on your quiz, when I said graph 210 degrees, you knew that went in quadrant 3 because it was between the 180 and the 270. You know those edges. The ones that we're adding today are 30, 45, and 60. Right? You probably know where they are, but we're gonna add stuff to them that you don't know, right? What you need to know about the unit circle is you're gonna be working with coordinate points, x comma y. The x values are actually gonna coincide with the cosine values. So when you see x, I want you to think cosine, and when you see cosine, I want you to think x. And the y values are gonna go with the sine. So when you see sine, I want you to think y, or if you're looking at a y, I want you to think sine. They go hand in hand. We're also gonna use, again, all students take Calc. And we're gonna think about what each of those letters mean. This means that sine, cosine, and tan are all positive in quadrant 1. This means that sine's positive, but cosine and tan are negative in quadrant 2. This means that sine is negative, cosine is negative, and tan is positive in quadrant 3. And this means that sine is negative, cosine positive, and tan is negative. We're going to use that again. So if you think back to your quiz from yesterday, you had to solve for the trig function, you had to get a reference angle, and you had to pick 2 quadrants. We're going to do the same thing. It's just when we solve for the reference angle, we're not going to hit second sign in the calculator because we're not going to have a calculator. We're going to use the unit circle, and then we'll apply the quadrants, all right? So we'll use all students take Calc again. So, you have this picture, all right? We're gonna start to draw in the unit circle. The first angle that you draw in the unit circle is 30 degrees. So if this is 0 degrees and this is 90 degrees, I know that 30 degrees is gonna be closer to the 0 than it is the 90. So I'm gonna try to draw this as accurately as possible without a protractor. So I'm gonna draw it somewhere towards the bottom. From here to here, that angle is 30 degrees. So I'm going to write 30 degrees here. Now eventually, you might have to solve a problem in radians. So I also need to know what 30 degrees is in radians. You'll either know how to do the math, we don't have a calculator, or you'll memorize it. That's totally going to be your preference. But the way to go from degrees to radians is to divide by 180. So I'm going to show you how to do that without a calculator. If you don't like that, you're going to have to memorize it, all right? So if I want to change 30 degrees to radians, I'm going to do 30 degrees, and I'll just put that over 1. To do our conversion, I need degrees to cancel out. So I'm going to put degrees on the bottom. And what I know is that 180 degrees is equal to pi radians. So my conversion factor is pi over 180. And if I multiply straight across, I get 30 pi over 180. The degrees cancel out. I need to simplify that fraction, but I don't have a calculator. So here's my mental process. See how the 30 has a 0 and the 180 has a 0? Since they both have a 0, I can get rid of that. So I could do 3 pi over 18. And now I'm working with smaller numbers. So is there something that I can divide both 3 and 18 by without a calculator? 3. So if I divide this by 3 and this by 3, 30 degrees is pi over 6. So you can either do the math or you can memorize that 30 degrees is the same thing as pi over 6. Your choice. But eventually you're going to get a blank unit circle for your quiz and you're going to have to formulate it. So you're going to get, okay, 30 degrees is pi over 6. Sometimes you'll be in degree mode and sometimes you'll be in radian mode. So it just depends on the problem. We okay so far? All right, so now this point right here is a point where my line meets my circle. Whenever you have a point on a coordinate grid, you have an x and a y value for that point. So I want to figure out what that x and y value are. You don't have to draw this part. But think about this as a reference triangle. Okay? Don't draw this part. But in terms of a reference triangle, I would use the x-axis and I would drop down from this point. This angle here is 30 degrees. It's a unit circle, so the radius from the center to the edge is 1. That's the special right triangle that I was showing you, right? This is the 30 degrees. This is the 1. We figured out that this was the short side, which was 1/2, and this was root 3 over 2, using the special right triangle rules. So this coordinate point is x, root 3 over 2, comma y, what did I go up? 1/2. Using that special right triangle. So what I need you to know, what I need you to have on your notes is this. In terms of the unit circle, you'll have a 30-degree angle. That 30-degree angle is going to be some line closer to 0 than it is to 90. That's the blue line. So you're going to have to generate the blue line. You're going to have to know that that blue line is 30 degrees, and in radians, that's pi over 6. And you're going to have to know that its coordinate point is root 3 over 2 and 1/2. And I promise you there is an easy way to memorize it, and I'm going to teach it to you once we get through the whole circle. All right? So that's the first one. The second angle that you're going to use for the unit circle is 45 degrees. Well, I know that 45 degrees is exactly in the middle of 0 and 90. So I want to draw this line right in the middle of the circle. Do your best to find the middle. All right? And this angle is 45 degrees. I also want to get that in radians. All right, so you can solve for it using conversions, or you can memorize it. So here's what I've got, 45 degrees, and I'm just going to put that over 1. And then if I'm making the conversion, I want the degrees to cancel out. And so I know that 180 degrees is the same thing as pi. So 45 pi over 180. All right, well, 45 times 2 is 90, right? And 90 times 2 is 180. So think about how many slices of 45 can go in 180. How many? 4. So 45 over 180 is the same thing as pi over 4. It's 1/4. You could divide by 5 and like keep checking that way too. The way that I think of it is, okay, well I know 45 goes into 90 twice, and 90 goes into 180 twice, so that's 4. So it's 1/4. So this is 45 degrees or pi over 4. And this point has a coordinate as well. I'm going to show you where it comes from. You don't have to draw the triangle part, all right? If I were to make this red line into a reference triangle, I've got a point on the circle, and then I drop that straight down. Here's my 45 degrees. It's a unit circle, so from the center to the edge is 1 unit. The radius is 1. So now this is a 45, 45, 90 special right triangle. We solved for those side lengths. So the x value was root 2 over 2, and the y value was root 2 over 2. So we go over root 2 over 2 and up root 2 over 2. At 45, the x and the y value are the same because a 45, 45, 90 is an isosceles triangle. It's got two of the same side lengths. You okay with that one? All right, so you don't need the triangle. Here's what you need. And this should be in your notes so far. The last one, the third angle, is 60 degrees. 60 degrees is closer to 90 than 30 is, right? So this last one's going to be just above the 45. So the line that I'm going to draw kind of splits the 45 and the 90, and this is 60 degrees. Now I want to write that in radians too. You don't have to work it out. You can eventually memorize it, but I'm going to work it out so you're seeing where it's coming from. So I've got 60 degrees, and I want to change that to radians. So my conversion is 180 degrees is the same thing as pi radians. So I've got 60 pi over 180. Well, let's get rid of those zeros. So we've got 6 pi over 18. What can I divide both 6 and 18 by? 6. So 6 divided by 6 is 1, and 18 divided by 6 is 3. So 60 degrees is the same thing as pi over 3. It's 1/3, 1/4, sorry, 1/6, 1/4, 1/3. 1/6, 1/4, 1/3. Now, 60 degrees also has a coordinate point. And it comes from the unit circle as well. So if I were, or sorry, the special right triangles as well. This is a point. That's the point that I want to know. If I drop this straight down, this angle here is 60 degrees. And the hypotenuse, because it's a unit circle, the radius is 1. This is a 30, 60, 90 triangle. The short leg is half of the hypotenuse, but the short leg isn't this one. You can see that leg's a lot longer than this leg. The short leg is half of the hypotenuse. The long leg is 1/2 times root 3, which we said is root 3 over 2. So the x value is 1/2, and the y value is root 3 over 2. You can see these are the same, but they're reversed. There's really only 3 values you're working with. Root 3 over 2, 1/2, and root 2 over 2. So this is what you need to work on memorizing. And it looks like a lot until I show you the trick. I'm telling you there's a trick, all right? So this is what you're working on memorizing. Here's a way to memorize it. All right, so what I do is I draw 3 lines. And I make my coordinate points. Every coordinate point, no matter if it's with 45, 30, or 60, all of them get a denominator of 2. Every fraction has a denominator of 2. So the first thing I do is I go through and I give everything a denominator of 2. Every one of those has a denominator of 2, okay? The next thing I do is 3, 2, 1, 1, 2, 3. So starting at the bottom, it's 3, 2, 1, and then starting at the bottom again, it's 1, 2, 3. Inside, 3, 2, 1. Outside, 1, 2, 3. All of the numerators get square roots. But the square root of 1 is just 1. So I don't need to write a square root over 1. All of the numerators get square roots. But the square root of 1 is just 1. It's a perfect square. Now it's filled out. Right? So you got to remember everything has a denominator of 2. 3, 2, 1. 1, 2, 3. Square root the tops. And then in terms of the degrees, it goes in order. 30. And then 45. And then 60. Right? It's smallest to biggest. And then fractions, you can either simplify that, or if you want to memorize it, those go in order too. So like 1/6 is smaller than 1/3. If you're getting 1/6 of the pizza, you're getting a smaller slice than if you're getting 1/3 of the pizza. All right, so 1/6, 1/4, 1/3. I don't expect you to have that memorized right now, but it is pretty quick and easy to memorize. All right, you're going to do it enough times in the next week that you're going to have it memorized. You don't have to memorize any other parts. It's just quadrant 1. We can use quadrant 1's answers to get to quadrants 2, 3, and 4. We can do work for that. We don't have to then draw out more angles. All right, once you have the unit circle, that's not even the actual unit, right? The unit is solving the equations with the unit circle. Okay, so solving what you did on your quiz, but now with the unit circle. So here's what we'll do. This is at the bottom of that page that you're on here. We're going to use the unit circle that we formulated to answer some questions. All right. The first question says, what's the sine of 30 degrees? What I need you to remember is that cosine is x values and sine is y values. So when I ask you what's the sine of 30 degrees, what I'm really asking you is what is the y value at 30 degrees? Because sine is what? So sine of 30 is saying what's the y value at 30. So I go to 30 degrees, which is right here, and I look at the y value, which is right here. So the sine of 30 degrees is 1/2. Cosine of 45 degrees. Cosine is x values. So what I'm really asking you is what is the x value at 45 degrees? So I go to 45 degrees, and because it's cosine, I look at the x value. So the cosine of 45 degrees is √2 over 2. The next one says, what's the sine of 60 degrees? Well, sine is y. So what I'm really asking you is, what's the y value at 60 degrees? So I go to 60 degrees, and because it's sine, I want to look at the y value. So the sine of 60 degrees is √3 over 2. Does that make sense? All right, so I want you guys to try the next ones. Same type of question, but now it's in radians. But you have the radians, right? Here's your pi over 6, here's your pi over 4, here's your pi over 3. And if you're stuck, I generated like a leading question up here for you. Your answer is going to be a fraction, 1/2, √2 over 2, or √3 over 2. You just have to figure out which one of those three it is. What do you think the cosine of pi over 3 is? 1/2. So if I go to pi over 3, cosine is x. The x value at pi over 3 is 1/2. So the answer to that first one is 1/2. What about the sine of pi over 4? Root 2 over 2. Pi over 4 is nice. 45 degrees is nice because it really doesn't matter if you're looking at x or y because it's the same thing. All right. So I go to pi over 4. Sine is y. So it's root 2 over 2. And then cosine of pi over 6 means I'm going to go to the angle pi over 6. Cosine is x. So I want to look at the first value rather than the second. This would be root 3 over 2. The only thing that could possibly change is those numbers might have negative signs. Think about what you know about a coordinate grid. In quadrant 1, x values are positive and y values are positive. Every angle you just worked with was in quadrant 1, right? 30, 60, 45 is all in quadrant 1. Well, what happens if I pick an angle in quadrant 2? What do you know about coordinate points in quadrant 2? What about their x values and what about their y values? Think about like if I plotted a point here. Negative x values and positive y values, yes? But remember, x is cosine and y is sine. All students, sine is positive, cosine is negative. So it ties with that all students take calculus thing. What if we put a point down here? What do we know about an x value down here? It's to the left, right? And down. So the x and y are both negative. Well, think about what quadrant we're in. We're in T. Tangent's positive, but cosine, which is x, is negative, and sine, which is y, is negative. So that makes sense. And then over here, x values, you're going to the right, so they're positive, but you're going below, so your y values are negative. So cosine is positive, and sine is negative. Well, we're in C. So we knew that already. So the only thing that's going to possibly change about our answers is not the numbers. Your answers are always going to be 1/2, root 3 over 2, or root 2 over 2. They might have a negative in front of them. And it depends on what quadrant the angle falls in. All of these angles were quadrant 1 angles, so everything was positive. But if it falls in quadrant 2, then the x value would be negative and the y value would be positive. So the last thing I want to do today is just show you some of these in different quadrants. It's not in your toolkit, so I'm thinking maybe you could flip your toolkit over, and I think there's a blank back cover. Add these 3 examples. Keep in mind that all of my final answers, when I get to the end of this problem, are going to be 1/2, root 3 over 2, or root 2 over 2. If you're like absolutely guessing on a test, you've got a 33% shot at getting it right, which is not bad odds, right? It's got to be one of those 3. That's the only 3 values we're working with in the unit circle. So, first thing that we do for a problem like this is, I can't be like, okay, what's x at 150? Because I don't know 150. I know 30, 45, and 60. So I can't use quadrant 1, at least not yet. Let's see what we know about 150 degrees. What quadrant is 150 degrees in? Does anybody need me to explain why that's quadrant 2? All right, so let's see. I know that 150 degrees is in quadrant 2. I also know that I'm working with cosine. So I want to think about what do I know about the x values in quadrant 2? Or if you don't want to think about it as x values, what do you know about the cosine in quadrant 2? So you could do like all students take Calc, okay? The answer to both of those questions is the same. The x values in quadrant 2 and the cosine in quadrant 2 have the same symbol. What do we know about x values in quadrant 2? They're on the left, so they're negative. What do we know about the cosine in quadrant 2? Sine is the only thing positive in quadrant 2. So what this is telling me is that my final answer is going to be negative. Does that make sense? All right, so my final answer is going to be negative. So now I'm like, okay, well, my final answer is going to be either negative 1/2, negative root 2 over 2, or negative root 3 over 2. I got to figure out which one. What you need to find is the reference angle. Quadrant 2 has a rule. If you don't remember what the rule is, draw the picture. Draw an angle in quadrant 2. What I know is that this is 150. But what I want to know is this. What's the relationship there? 30 degrees, right? So the angle that I want to refer to is the 30-degree angle. I know what the 30-degree angle is. So my reference angle is 30 degrees. So what that means for my answer is I want to use the coordinate point at 30 degrees. We have that generated here. So at 30 degrees, we have root 3 over 2 and 1/2. Everybody okay so far? Why I'm picking 30. Okay, well, let's go back to the question. It's cosine. So which of those two coordinate points do I want to use? X or Y with cosine? X. I want to use the X value. So I said my final answer is going to be 1/2 root 2 over 2 or root 3 over 2. I got to figure out which one. I just figured out which one. It's root 3 over 2. Okay? I also know that my answer is going to be negative, though, because 150 is in quadrant 2. And x values are negative in quadrant 2. Cosine is negative in quadrant 2. So it's not just root 3 over 2, it's negative root 3 over 2. A little bit more of a process than just directly it being in quadrant 1. But we didn't use a calculator at all. All right, let's look at the next one. 240. Let's think about what we know about 240 before we dive into anything else. 240 is in what quadrant? Does anybody need me to explain why this is quadrant 3? We're okay with that. Okay, so what do we know about either sine or y values? You can think of it either way, because sine and y values are the same. So you can use prior math knowledge, or you can use all students take Calc. But what do we know about sine in quadrant 3? I know tangent's positive in quadrant 3. Sine's negative in quadrant 3. I know that quadrant 3 is values to the left and down. So x and y are both negative. So they are negative. And that means when I get to my final answer, whatever I choose, whether I choose 1/2 root 3 over 2 or root 2 over 2, it's going to be a negative. We okay with the symbol? All right, now I have to figure out which one of those is it going to be. So I can use a picture if it helps. I know that this is something in quadrant 3, and I know that this is 240, but I only want this piece of that. How do I get that? What's the rule here? Minus 180. So I'm going to take my angle, 240, and I'm going to subtract 180, and we're going to do it the old school way because we don't have a calculator. You guys remember how to do this. It's been so long since you've done this, all right? You're going to start with the right-hand side. 0 minus 0 is 0. You got to grab from that 2. You're going to make the 2 a 1, and you're going to make the 4 a 14. And you're going to do 14 minus 8. You can even count with your fingers. 8, 9, 10, 11, 12, 13, 14, 6. All right, it's not that much. You're either going to get a 6 or a 3. All right, so 60 degrees is my reference angle. So that means when I want to find my answer, I'm going to refer to the 60-degree angle to get it. That's what reference is actually meaning. I'm referring to this end. All right, so what I know about my 60-degree angle is that the coordinate is 1/2 √3/2. And you don't know that yet, but you will. You'll memorize it. So here's what I know about my reference angle. X, Y. I'm working with sine. Is sine X or Y? Y. So I want the Y value. I knew my answer was going to be 1/2 √3/2 or √2/2. Now I know it's √3/2. I also have to incorporate the fact that I also know it's going to be negative because I'm in quadrant 3. And the Y values are negative in quadrant 3. Sine is negative in quadrant 3, so I'll add a negative to that. This is the only time that radians is easier than degrees. This is the only time. Because my reference angle is so obvious. See how the angle that I want is over 4? My reference angle is going to be over 4 too. Because no matter what math I do, the denominator of an addition and subtraction problem always stays the same. So no matter if I add 180 or subtract 2 pi, it's still going to be over 4. So this is the only one where I don't have to do work to get the reference angle. I know the reference angle is going to be pi over 4. Just based on the denominator alone. If this was 7 pi over 6, then the reference angle would be pi over 6. If it was 11 pi over 3, then the reference angle would be pi over 3. I don't have to do the work. I don't have to draw the picture. That's the reference angle. So I know that I'm working with the pi over 4 relationship. And in this case, it doesn't even matter if I'm looking at X or Y. My final answer is going to be √2/2. The only thing I need to decide is the √2/2 positive or negative? That's where the quadrant comes in. All right, so let's think about 7 pi over 4. All right, well, 7 pi over 4 is the same thing as 1 3/4. All right, if I were to write that as a mixed number, we okay with how I got that? 1 3/4. You guys know what 3/4 is as a decimal, right? It's like that's common knowledge. What's 3/4 as a decimal? 0.75. Okay, so this is 1.75 pi. And let's think about what we know. We know this is 0.5 pi. This is 1 pi. This is 1.5 pi. This is 2 pi. So where's 1.75? Somewhere between 1.5 and 2. So my answer is in quadrant 4. What do we know about quadrant 4? What's positive in quadrant 4? Cosine. So sine and tangent are negative. So if I'm working with a cosine, then my answer is going to be positive. And if I'm working with a sine, then my answer is going to be negative. And I'm working with a cosine. Cosine's positive in quadrant 4, so I don't have to add a negative to this answer. It's just √2/2. Obviously, that is a lot harder than this if it's in quadrant 1. But that was true about last unit too. If it was in quadrant 1, reference and standard were the same thing. We didn't have to do any work. All the other quadrants, we had to do work. So we're doing work in other quadrants here too. So my closure for you is I just want to see if you can try them. Just give it a shot. Worst that can happen is you're guessing wrong. You have 3 guesses. 1/2, √2/2, or √3/2. Take an educated guess if you don't know. Okay? And then right in like 10 minutes, right before class is over, I'm going to post the answers. I like to figure out the quadrant first and then decide if my final answer is going to be positive or negative. And then from there, I find my reference angle. 2/3. Which door you want to find? You know what 1/3 is a decimal? 2/3 is 0.67. Alright, so I'll be thinking where is 0.67 in relationship to 0.51, 1.5. So that's a quadrant. Then you decide it's positive or negative. So that is 4.2. Using yes, that was good. This one is a quadrant. 30. Another one. That one's good. This one's 45 and it's that's right. So, I like this one as verse number 2. That one is of 210. So what angle did you use as your reference? So think. So 30 degrees. So go to the 30-degree angle. You're right. It's 30 degrees. So then I'm in 30 degrees and 3 over 2. Yep.
So is that right?
I didn't say what.
Oh, that's what I thought.
No, you had road sign. Actually, it's not right because it is sign. It would be right if it was cosine. But now it's sign, so you want to use the y value.
Oh,
So you copy it. But you're in the right spot. And sign in that quadrant is negative. What about sign in this quadrant? Now, 2 pi over 3, just simply because there's a 3 there. Your reference angle is pi over 3. You don't do any more. So you want to use the coordinate point at pi over 3. Well, so in terms of these ones, I needed to use 30, 45, or 60, right? In terms of radians, I need to use pi over 3, pi over 6, or pi over 4. Those are the only ones I have. The fact that that has a denominator of 3 means which one I'm going to use on this. It's comparable to pi over 3 because it has the same denominator. So I'm going to use the coordinate point there, which is 1/2, comma, root 3 over 4. You have to figure out which one you're going to use, right? And then you have to think about what quadrant it's in. So that one's a little tougher. Well, do you know what decimal 2/3 is? Okay. Do you know what half of 3 is? Okay, so it's 2 more or less than that. This is in the 5. Bigger than 1 point, right? So this is, no.
The third quadrant is not.
So 1/2.
Oh.
1.5 over 3 is 1/2. 3 over 3 is 1. So it's somewhere between 1.5 and 3. Okay, so let's think. We're in quadrant 3. Let me just draw your picture. This is 180. So I'm going to do that. It's always either 180 or 360. You never use 270. All right, so here's what I got. I knew my reference angle had to be pi over 3 because the only reference angles are pi over 3, pi over 6, and pi over 4. And the fact that that has a pi over 3 in it makes that obvious. So I want to focus in on the pi over 3 stuff. And the x value is 1/2 that pi over 3. So I knew that my answer was going to be a 1/2. It was just a matter of is it a positive 1/2 or a negative 1/2. And that comes from what is this as a quadrant. I know that 2/3 is 0.67. So I was thinking, where is 0.67 in relationship to 1/2 and 1? It's right in the middle, which made this fall in quadrant 2. Cosine is negative in quadrant 2, so my answer is negative 1/2. Sine of 210. Well, 210 is in quadrant 3, and the quadrant 3 rule is that I need to subtract from 180. So I did 210 minus 180 and got my reference angle to be 30 degrees, which means I'm working with the 30-degree relationship. And because it's sine, I want the y value, which is where the 1/2 is coming from. And then I just need to decide, is it positive or negative? Well, in quadrant 3, tangent's positive, but everything else is negative. So I put a negative on the 1/2. And then the last one's 315. 315 is in quadrant 4. So I know I need to subtract from 360 in quadrant 4. So my reference angle was 45. So either whether I'm using x or y, I know my answer is going to have a root 2 over 2. I just need to decide if it was positive or negative. Well, sine is negative in quadrant 4. If this was cosine of 315, it would be positive root 2 over 2. But because it's sine, sine is negative in quadrant 4, so I put a negative in. All of that is without a calculator. Your test is without a calculator. What do you guys think? Alright, so we don't have any homework. We'll just build it. So tomorrow what we're going to do is solve equations. You already know the process of solving equations. We're just going to do it without a calculator. So we'll find the reference angle from the same way we did today.